we were done with this one, right? Okay. So let's start with a bit of history. How many of you created APIs? How many of you consumed it? All right, great. So I'm guessing everyone here created REST APIs, and some of you might have been old enough to do SOAP and other things, but I think RESTful was the thing when GraphQL happened. So my talk is about GraphQL, and although it's in the mobile development category, but it's on the both side, because I had been to both sides. I created API and I also consumed it from a mobile app. So I will be talking from both the perspectives. And so to begin, let's start with some history. If you created API, I think you had some frustrating moments like this. This is a simple API. Then you have an API for the post. Then you have an API for a single post, and vice versa. I'm not a good API creator, and I cannot follow RESTful specifications. So this might be wrong for some of you, because API is very opinionated. So I also included another version, a simpler version. But I think you get the point. REST API, when it's simple, it's nice, but when it gets complicated, it might be harder to communicate. Okay, it's not straightforward. Like if you say that my name is Anam, it's very easy to communicate. But for the REST APIs, you need API documentation, because it gets harder to communicate with growing complication. And there's this. This one is from one of our applications before. My colleagues are smiling. So this is from one of our applications, and I'm highlighting only the XHR parts, the things that are being fetched with Ajax. And you can see, to render one page, you have to call 90 APIs. And if you see the other side, it takes 13 seconds to load a single page. So it's already bad for performance, but if we ask Google, you can be more sure, because out of 100, this page gets 12. So this is one of the reasons REST API can be a pain in the, I'm sorry. And there's this other thing, mobile screens are small, but computer screens, they are big. So you can show more information in computer screen than on mobile screen. But even if you don't want to show something on, say, your mobile screen, with traditional REST API, you have to fetch that data, even if you don't want to show it. Because REST API is designed in that way. If you want to avoid that situation, you have to create a different REST API. When I was going through the GraphQL presentations on YouTube, just to steal some of the notes from them, there was this one guy named Dan. He's the inventor of GraphQL. He had this analogy. He said, REST API is like a vending machine. If you want a Coke, you give it a coin and you press a button. If you want, say, a different type of soda, you give it another coin and you press another button. If you want the Coke and the soda to come at once, you have to invent a new button, and the number of buttons increases. So does the complexity. But GraphQL makes it easier. We will see how, but this was the problem back in 2012 when Facebook was trying to rewrite their mobile app for iOS. Any of you happen to know the HTML5 disaster of Facebook? So Facebook tried to write their app in HTML5. I don't know what was going on inside Mark's mind, but trying to write a mobile app as complicated as Facebook with HTML5 is a very bad idea. And they had to pay a price. Their app was very bad. So when iOS 5 was released back in 2012, they wanted to rewrite the whole app, and there's a saying that they actually created a new app. They went to the file menu and hit new, and from there they did it from scratch. But when they started this project, mobile app project, they also realized that a big part of their bottleneck was their API. So they had to do something about the API as well. So Dan came up with this idea of GraphQL, rethinking the API. And back in 2015, GraphQL was open sourced. When it was open sourced, it was adopted by a lot of companies, including Airbnb and Twitter. So the story goes on, and then GraphQL conferences started coming up, and many cool things happened. But I think I made my point with this story, why GraphQL came. So let's not elaborate on this story anymore. Let's see some code. I'll start with the server-side code of GraphQL, but this is by no means a working code, obviously, because working code would be longer, and being a JavaScript developer, it will lean towards JavaScript. I tried to make it as close as pseudocode, but this will lean towards JavaScript. So this right here is a GraphQL schema. So you have to define every object type in GraphQL. This is one type of object, which is a person. You see, it's very similar to JSON, but it's not JSON. And the exclamatory sign beside the type is for the required field. So every field that has a exclamatory sign, it's a required field. And this is a built-in type in GraphQL. It's called query. This is how you fetch data from GraphQL servers. So every time you have to do something with the data, you have to write a schema in GraphQL. Then you have to write a resolver for GraphQL to know how this data is going to be fetched. So this is a simple resolver that's for this schema. To fetch a person, you just need one line and nothing else. And if you're working in a production grade environment, this is all you need. I will explain why. And this might be, say, finding from a MongoDB database or RDBase or whatever. GraphQL doesn't care. And I mentioned async await here just to let you know that GraphQL resolvers can also be async functions. And that's all you need to do in server side. From the client side, you need to ask what you need. So if you remember my person schema, I had three fields: name, ID, and age. But for example, I'm fetching this data from a mobile app, and I don't need the age or ID. I just only need name. If I run this query in the server GraphQL, then I will get this response. GraphQL will fetch, my code will fetch the data. It will hand it off to GraphQL. GraphQL will see what I want. GraphQL will remove the other fields and only give away this field that I requested. And the good thing about GraphQL is it has batteries included. Batteries like type checking. When I created this schema, I also mentioned the type of the data that is going through this GraphQL. So type checking is built in inside GraphQL. Validation. Because I'm mentioning type and because I'm mentioning the requirement, also I can use custom scalars to extend this validation stuff, so I can do the validation in GraphQL layer rather than going to the database or going through another validation layer. Error handling. When I said that one line is enough for you, whenever you throw an error from a GraphQL resolver, you can catch that same error from your client. You don't need to worry about server-side error handling. GraphQL will handle it for you, and it will transfer it to the client. And sanitization. So, for example, if you have a database and you have user information, you probably have the hashed password as well. So, when I did this here, I did not strip the password, but GraphQL will do it for me because it's not in my schema. So, these data will not be passed. Here are some useful links. I know these links, these are no-brainer links, so you don't have to memorize it. You just need to search for GraphQL and you will land on the right page. One thing I have to mention that Apollo is a good server and client-side component for GraphQL. There are other implementations, but Apollo is so far way ahead of their competition. And Apollo is made by the same people who made Meteor. And so far that's it.
You have a complex GraphQL API request which possibly joins multiple entities. When in the backend, does that go as one SQL query to the server, database server, or does it like generate multiple SQL queries? Is there a way to like just make one database query for such cases?
You can definitely do that. It comes down to the ORM. For example, if you're using Prisma, it will handle it for you. But if you're using any other ORM, you have to code that in.
So there is a bridge from the GraphQL API layer to the ORM. So
there's Prisma. There is a bridge.
So every ORM then has like a library that has that people write a bridge for.
No. Prisma is closely integrated with GraphQL, but any other ORM you have to write it by yourself.
Understood. Okay. Thank you.
So hi, I'm Asam from Vikas. Something related to what my last person was asking about. We know that GraphQL is simplifying whatever data is required from the client. So the client has the decision-making power, like what data will be fetched. So isn't from the server's perspective, how do you, in terms of scalability, because the server doesn't have any control, like what the client is pulling. Once the schema is there, which might have like thousands of entities, related entities, what kind of scalability measures or problems have you faced in your experience?
Well, one thing that the previous person was mentioning, that multiple queries, that was one problem that I had to face. But if you are creating a GraphQL backend, you have to think like a GraphQL developer. If you're creating a GraphQL backend, having REST in your mind, it will cause problem. If you architect your application in such way that it can, I think these kind of bottlenecks can be avoided. When I started out, I had the same problems, but gradually when I started thinking like a GraphQL developer, it changed. GraphQL has a lot of resources by itself. If you go to their GitHub repository, it has a lot of examples and good practices.
Okay. I was curious a little bit about whether it's actually REST, which is translated to by the server end. I mean, at heart, it is a REST request, is it?
At heart, it is a POST request.
It's a POST request, yeah.
Even if you are getting some data, it is a POST request.
Okay.
You are sending your requirement in that schema, so it's always a POST request, even if you are fetching a data, and every time you are getting some data back. So even if you are creating something, you will get something back, whether you want it or not. If you don't want it, you just don't ask for it. That's it.
Is there any way I can request the same through sockets, web sockets?
Yeah. GraphQL actually has something called GraphQL subscriptions. So it's a PubSub model.
Oh.
So you can do it.
Oh, thank you.
Or do I have to know it beforehand?
you can request the schema if you are authorized to request the schema. You can restrict someone to not to request the schema, but you can always also allow it, but you can also turn it off.
Can you break up the schema into different and reply, like give different people access to different parts of the schema?
Yeah.
I wanted to know, especially like if you're using something like GraphQL, is there any paradigm issues related to ASMS and Dhaka's both of the question? Like, if you're using, is there a thinking pattern like a NoSQL sort of thinking pattern you would be needing for using something like GraphQL when you are referring to the architecture or how to develop, like a GraphQL developer? Okay.
It's a bit hard to explain, but when we think about RESTful APIs, we think about one request as one resource. For GraphQL requests, you are actually requesting multiple resources. So what I had to resort for my project, I created an adapter for mongoose, and then all my queries go to that adapter that runs my query, keys back my data, and then I can serve it with GraphQL, so that I can do it with one go. Because the server that service that I was using for MongoDB, it has billing per transaction. That's why I had to do that. API knowledge